Welcome to our webcast. This is the Wireless Works webcast sponsored by Cambium Networks. My name is Daran Hermans, and I'm glad you joined us today. We're going to be talking about a great topic. It's you've probably heard quite a bit about it. It's starting to really come into our vernacular, which is Wi-Fi 6E. We're joined here today by Mitchell Parsons. He's one of the internal experts at Cambium, one of those people that works behind the scenes, actually works a lot in front of the scenes as well with customers on some of their network deployment issues and some of their tricky stuff. Mitch, give us a quick introduction. Tell us what you do at Cambium Networks.
Thank you, Daran. Basically, I help out with all of our products. I mean, whether it be Wi-Fi or our new 28 gigs equipment, our 60 gigahertz CN-wave stuff. I mean, so I run the whole gamut. I guess wireless is my thing, along with our switching and routing capabilities that we have on our CN switch.
That's a broad scope. Everything from 5G NR to 60 gigahertz to just plain old Wi-Fi. So we're glad you're slumming it with us down here in the Wi-Fi world today. I just deal with Wi-Fi. That's what I do. Wi-Fi is exciting though. It's been around a long time, but lots of great changes and lots of good things to do. So I appreciate you being here today and bringing your insights and your experience to this topic. We're going to talk about Wi-Fi 6E. And first of all, let's start answering what are the problems that we are trying to solve when we talk about a new technology. So we got new technology coming out. Why do we need Wi-Fi 6E? And so let's talk about that. So Mitch, what are some of the things that have been a problem for Wi-Fi over the years? What do we need to solve here?
I mean, first off, Wi-Fi is over several different bands, and it's not contiguous, right? So we don't really have a lot of channels that sometimes we hop around, right? Because the Uni 1, Uni 2, Uni 3, there's breaks in between, as well as we have the DFS in there with Doppler radar. Well, the new 6E standard is 1200 megahertz across the board, contiguous of channel space. So there's no breaking of channels.
Mm-hmm. So one issue right there you brought up, which is that the discontiguous channels in Wi-Fi. It's chopped up. But what else? I mean, Wi-Fi has been around a long time. So does that cause a problem?
Well, of course. I mean, I kind of, you're kind of talking a little bit about, why the upgrades, right? I go back to the adage of every time you build a better mousetrap, they build a better mouse. Well, users are pushing this, right? With the more stuff that they do, the more power they need, less latency on the applications that they're wanting to use. So, the upgrade processes that we're going through is really being pushed by network utilization and how networks are being used.
Yeah, and probably I think equal to that is that nobody throws anything away. I tried to throw away an old printer I had, and my son said, "You can't throw that away. It's the best printer we've got. The thing is 10 years old." But it's a nice printer. He likes it because it's got the scanner on the top. It's got all the functionality. But I can't seem to get rid of that old printer. So yeah, we don't throw anything away, do we? And
no, we don't.
Not in the home anyway. So that also adds to the problem of Wi-Fi. You get contention management, trying to manage the contention from all these different protocols, all this old stuff, trying to compete with the new stuff, and quite frankly, despite what the Wi-Fi Alliance wants to tell us, things do change, and they don't necessarily work well together. With older technology and newer technology, it doesn't always work well together. So we got a problem. We got a lot of problem with contention, RF contention. We have a problem with density, more devices. We have a problem with range, channel utilization, packet size optimizations. We've got lots of issues with Wi-Fi that have built up over a long period of time. So Wi-Fi 6E. So the key thing about Wi-Fi 6E that we'd like people to understand is that it starts out with a protocol that is designed at the protocol layer to address all of these issues. So that's the 802.11ax protocol. So Wi-Fi 6E is 802.11ax running in a new frequency, the 6 gigahertz. So before we talk about 6 gigahertz, and that'll be a longer topic, let's talk about this underlying protocol, 802.11ax, and how does it solve some of these problems that we just been talking about. So Mitch, you've seen, all these different protocols. 11ax has been out for a few years. What's top of mind for you? What jumps out first that you think is probably the most important, or just not maybe not the most important, but what's a part of the 11ax protocol that you like the most?
I would say the OFMDA and resource units. I mean, that there alone allows for some of these older clients who don't necessarily use as much as the bandwidth as some of the newer clients to be able to kind of fit in, and allows a control of that airtime that you didn't really have before. So this, and it does it both in the up and downward direction. So it allows me to talk to multiple clients, only give them the amount of resources that I need to give that client to be able to do that communication. So if I've got like a low throughput device, like an IoT device, I'm not using that whole space. Of course you've got multi-MIMO mu, right, in the up and down direction, and I'm going to use the number of streams that I have, but resource units kind of get that down to a further packet size or packaging to allow for more communications in a given airtime space.
Okay, so let's contrast that OFDMA with the previous generation OFDM, because they sound almost the same. It sounds like we just put an A on the end of it for some random reason, but actually they do mean completely different things. So let's go ahead and contrast OFDMA, which is introduced with 11ax, with OFDM from, just literally a couple of years ago, right?
Right.
802.11ac was OFDM. So what is the difference? It just how does the packet behavior difference change? How does the packets change, and the access to the RF medium change with OFDM versus OFDMA?
Well, I'll actually take this from OFDMA's side. So
Okay.
the A stands for access, right?
Mhm.
And wireless is a contention protocol. So if I hear somebody talking, I basically have to be quiet and allow that communication to go on. And we have the things in there that kind of help out with that, with random back off and stuff like that. So where if two people talk at the same time, then there'll be a randomness of when they try to talk again. But with the OFDMA, now wireless is a little bit more like a switch than just contention based and one person talk at a time. So that OFDM helped with being able to packetize the resources into utilizing as much wireless space as I needed. But then the A added that access, the multiple access to it, to allow for these clients to be able to truly use that airspace. And then I've said the word airtime utilization and stuff like that, but really airtime utilization is one of those things that kind of similar to our old time wired network utilization, right? When you got up to around the 80%, that means you were totally saturated. Well, 80% is not really something that you can get out of your wireless in a sense, because I have a lot of retransmit. It's not a one-to-one link. Well, the FDMA, allowing for multiple people to talk, reduces that contention, reduces that airtime, and allows more clients to be able to talk fairly across that period of time.
Right, right. So you focus on the key thing there. The M in OFDMA stands for multiple. The A is access, so multiple
Right.
access. Whereas OFDM, the M stood for multiplexing. So the same letter M, but in one case, but they mean different things. So with OFDM, the challenge there on the flip side of that coin we just talked about, with OFDM with 11AC. Every transmitter, and you mentioned earlier that Wi-Fi is a contention-based protocol, so that means that every time slot, only one device can transmit in a time slot. So whether the packet being transmitted is just a small management frame, could be a voice packet, it could be just an acknowledgement packet or something. It could be a very small packet, 64 bytes. It could be as small as that. It could be a large frame of a video frame, 1348 bytes. But whether it's a large frame or a small frame, it's allotted that same time slot to transmit, and it used the entire frequency. So it's very wasteful. In fact, some networks that I've seen, up to 70% of the traffic on that network are very, very small frames. So when you see 802.11ac and it says, well, this is an AC 3200, which theoretically says it's 3.2 gigabits per second. Have you ever gotten 3.2 gigabits per second off of an AC 3200 access point? No,
No.
and you never will. And you never, ever, ever will. So it's because it is a contention-based protocol, you're never going to be able to utilize it 100%. That's the problem we're trying to solve here. And then you start to double up your devices. Every year we buy something new. We don't throw away the old stuff. My house right now, I've got 19 things on my network at home right now. Didn't think I'd ever get to that point, but I'm not even. That's not even a big number for some. For some people, it's even more than that. So our networks are getting more dense. Again, we're still transmitting these small packets. We're just wasting time, is what we're doing. And OFDMA solves that waste of time by allowing, again, the M, you mentioned the M and the A, the multiple access. It allows multiple devices to transmit at the same exact time using smaller sections of frequency. So take that frequency, whether it's a 20 megahertz channel or a 40 megahertz channel, break it up into small resource units, allow individual transmitters to transmit at the same time using these dedicated little slices of frequency. That's OFDMA. Now, so another key thing about OFDMA and this technology with 11ax is that somebody has to be in charge. It is a contention-based protocol. You still have to deal with contention. Even with OFDMA, you have to deal with devices that contend and might interfere. So something has to be in charge of this. And in 11ax, that something is the access point. He tells all the clients when to wake up, when to go to sleep, when to transmit, when to receive, and what resource, very importantly, what resource units are you allowed to use for your particular transmission. So that creates what we call a deterministic network. So let's talk about one other thing. When we're talking about this, again, contention, how do we manage contention? Inside my home, I have one AP, pretty easy to deal with, right? Not a big problem there. But go into an enterprise space. Go into enterprise space where you have dozens of APs. The largest network that I ever worked on actually is still I think it's still the largest deployment in the world, is as a hospitality / gaming of 47,000 access points. That's not hyperbole. That's a real network. 47,000 access points. Now they're not all in the same one space together. They're spread across multiple buildings. But some of the buildings have as many as 3,000 or 3,500 access points in a single building. And again, break it down into areas and zones, right? Some zones are not contentious zones. Some zones have a lot of APs, a lot of users, a lot of high density. And so now you've some zones have a big problem with contention. So how are we managing contention when we have multiple access points in the same geographic area connecting to their clients and trying to optimize those clients? How does 11ax help in that situation?
Well, they kind of take a hint from other wireless protocols where they come up with color codes. So if I have a color code, I can have individuals on the same channel. And if I'm at a client where I'm at an edge where I can hear both of them, if it's not my associated color code, I don't care that that's transmitting. I can still transmit. So I mean, this color coding allows for reuse of the same frequency for clients and for allowing them to be subscribed to their particular AP, as opposed to where we used to, there was, if a client heard a beacon or a transmit on the same channel that it was listening on, and even though it was a distant AP, it still had to go quiet. So this color code scheme really helped with being able to make those cells more efficient of where this AP cell is talking to these clients and this AP cell is just talking to these clients, just by using that color code and that frequency reuse.
So, all right. So you have to explain color to me. I'm not colorblind, but do you mean like, are they red, green, blue? What do you mean by color?
Color is just a number, and they call it a color code, but it's basically just a number that's associated with a particular AP. So whenever that beacon is, that number code is in there, and so that way it knows that, hey, that's we call it a color code, but it's not red, green, blue, right? Because I mean, at the end of the day, clients and APs, they are colorblind. They don't really see colors. They see ones and zeros. So we get this down into a number.
Okay, all right. So color is just more like a metaphor. Helps us lowly humans understand what the APs and the clients are doing. All right, good, good. So they have this ID, this identifier. We're calling it a color that says that this client belongs to this AP, and let these two guys talk, even though they can see another one over there in the same geographic area, they can ignore him. Cool.
Exactly.
All right, excellent, excellent. Good. So this is good. A good introduction for a couple of the things. We just talked about a few things, only a couple of things here, but this is nice. Talking about 11AX and what its advantages are. And we clearly identify that these advantages with 11AX deal with the idea of dealing with increased contention, higher density devices, and being able to manage it better. Now, the nice thing about that, as we're talking about it, is for people that read the IEEE standards, you may have seen the term high efficiency, and it's actually right in the title. High efficiency is in the title for 802.11ax. So it was a goal of making this technology deal with contention in an efficient manner and make better use of the spectrum from day one, built into the standard. So now 11AX solves a lot of these issues with contention and dealing with more devices, doing lots and lots more packets, small packets and large packets. So what's holding back 11AX? Is there something else that can be done?
Well,
What do you think?
I mean, we've upgraded the protocol, but we've not upgraded the physical media that it shares. I mean, we're still sharing that same media with that old stuff that, as you said, hey, we don't like to throw anything away. If it works, we keep it. We want to squeeze every little bit of life that we can get out of that. Well, now we're still left with, okay, got a great protocol, but the media is still not quite up to what we need. Well, thus Wi-Fi 6E, right? We create a whole green field of frequencies that are totally untapped and unused generally for the Wi-Fi level. So this is kind of, hyperdrive for this new protocol of being able to be fully utilized to provide that high efficiency, less contention network.
Okay, so you bring up a new frequency, so 11AX in that new frequency. Before we talk about that, that answer actually leads into another question. We should probably take a side trip and discuss a little bit. Why should we even be talking about Wi-Fi at all? You can't watch TV in any primetime slot these days without seeing 3 or 4 5G commercials. All the carriers are advertising 5G. They're pushing it. It looks like it solves every problem since the beginning of mankind. Why not 5G? Why doesn't that just take over, just replace Wi-Fi completely?
So why doesn't it? I mean, you've got a very large spectrum that 5G covers, right? All the way down to, the megahertz, all the way up to, gigahertz in the sense of, 28, even up to possibly 30 gigahertz, depending on what country you're in. There's a very large range and a lot of different radios that are being utilized there to provide this capability. Well, okay, so you start looking at, the lower end, doesn't really get us, much throughput, right? Not like what we're going to get out of the AX standard. A higher end will get us that throughput, but it doesn't really get the penetration and go through items like or obstacles like 6 gig, 5 gig frequencies do. So it's kind of limited in that spec that you're not really going to be able to run a 5G network in your home, or sometimes even in your business, in the sense that it's not going to have that same penetration or the same capability. As well as the fact that now you start talking about a very specific chipsets, radio, devices designed for multiple radio use, fractal antennas, really expensive, right? Whereas, the Wi-Fi 6E available chipsets, the antenna design is a little bit more simpler than what we would do in a 5G situation. So, 5G, yes, it's great. We needed that technology. There's a lot of things in 5G, the ability for vehicles to talk to vehicles, the ability to now have something that's provides streaming to the home over wireless. Not necessarily looking for cables or fiber or some kind of copper conductor. So I mean, there's a lot of things that 5G helps with, but in the end, in the enterprise level, it doesn't really solve the problem that we have, where the ability for people to bring in their current devices and be able to use, as well as bring in their newer devices with this new band, the 6E, the new Uni 5, 6, 7, and 8. It's as far as the antenna design goes, now I'm only going across to a 2 4 band and a 5 and a 6 gig band.
Okay,
So I mean,
yeah. So let me ask you though. Let me just keep throwing this at you because I've heard a lot about open 5G and private LTE. So I understand what you're saying because the carriers, the main carriers, they control all that frequency, that upper band frequency, mid band frequencies, and I have to use whatever they have, right? I don't get a choice. But what if I wanted to do my own? If I'm an enterprise and I want to build my own private network using 5G or LTE standards, why can't I do that and replace Wi-Fi?
I mean, you could, but then you're going to have some kind of security method. Usually we do this with SIM cards, right? That's what's in your cell phone. So that's not really going to change. So we're not going to do security similar to what we do in the Wi-Fi arena, 802.1x with a radius type server or certificate types capability. So now we've got a specific card we got to put in a device and track. The packet core itself is it's very what's the word I'm looking? Modular. That modularity capability requires expense. So it's not necessarily something I'm going to bolt on to my current wired network. This is going to be a separate network I run on top of running my wired network. Whereas in the Wi-Fi arena, I'm just plugging it in basically to a switch port, getting PoE, and I'm up and going. I don't really have that additional network interface to have to deal with.
Okay. Go ahead, keep going.
I was going to say, and on top of that, some of the manufacturers that have provided your own private, LTE/5G, they provided some cloud control. But so now you're going to have a recurring expense that you wouldn't necessarily have in a Wi-Fi, right? Because I plug it in. Maybe I have my service requirements, that I'm maintenance that I'm paying for, but not for use. I'm not paying for use. Whereas in the 5G, I am going to be paying for use.
Okay. So I think it gets back to where we started this conversation to begin with, which is what problem are we trying to solve? And what technology, because at the end of the day, 5G, LTE, Wi-Fi, these are radio frequencies, right? These are electromagnetic spectrum frequencies. But implemented completely different way to solve problems. So what problem are we really trying to solve? I guess it comes back to that. And that's what we'd recommend people do it, is always ask that question. When it comes to technology, what problems do you have and what problems are you trying to solve? And see if pick the best technology to do that. So as we wrap that up, let's go ahead and answer that question. Why not 5G from the point of perspective of what problem are we trying to solve, and why is Wi-Fi here to stay?
I mean, you're trying to solve a connectivity problem, right? Whether it be that I want roving clients, or I don't want to put the expense in of putting 4 drops per pylon, in an office space. Maybe it's not as utilized as it was before, or maybe it would be utilized. I want the ability to support a VoIP system. 5G would say, hey, well, we do phones, we do mobile. You have your cell phone, right? Well, yes, but whenever I do 5G, I'm bolting on something, right? Whenever I do a Wi-Fi upgrade, I'm adding on to something. It's not. There's not a. I'm still working with what I used to have compared to, and then adding on to what I have to add the capabilities. Whereas in a 5G network, I'm just bringing up a whole new network that I now have to manage and maintain to provide that connectivity.
That's a good point. And the 5G standards really were designed from the outside, from the carrier network, to give the range and the performance for those outdoor networks. And whereas, in contrast, Wi-Fi started, the name is WLAN, right? Wireless Local Area Network, WLAN. That's where it started, and that's where it still lives and exists, is in the wireless local area network. And ultimately, that's where Wi-Fi is going to still be, and that's why it's still here and going to continue to be here, is because you're still having access to your local content. It's your local data. You apply your local company's security policies to Wi-Fi, to this WLAN. It's everything you continue to do and you have been doing for the last 5, 10, 15, 20 years. It's just that with new Wi-Fi 6 and Wi-Fi 6E, things get faster, less contention, higher density, better utilization of the electromagnetic spectrum, and so just faster overall, better performance. Continue, but still maintaining that simple wireless local area network concept. All right. Well, thank you very much. This has been a good introduction, Mitch. And Mitch, stay with me, because we want to do some more work here. We want to talk to people about, in a future webcast, I want you to come back and talk to us again about Wi-Fi 6E. And we'll get into some more topics like, what is the impact on the network design? You know, we've set a pretty good job here today, really establishing Wi-Fi is familiar. It's what you normally do. 5G is completely different technology, but Wi-Fi 6E will introduce some changes to the network topology and network design that people need to understand. And so please come back and join us again on a future webcast, and we'll talk about that in a little more detail. So thank you very much.
Thank you.